This requirement to be in the same plane and strong preference to be anti leads to some cool chemistry for cyclohexanes and E2 reactions. So for example, if we draw the cyclohexane with a chlorine pointing up and then a hydrogen pointing down, we can easily do an E2 here because these two are anti to one another. But if we drew this molecule like this, now we can't do an E2 since they are not anti to one another. Now, obviously, in this case of this molecule is free to chair flip, and so it can go in the conformer where E2 does occur. But let's take a look at another molecule. So we have the chlorine here, and then we'll put two methyl groups right here, and then we'll draw the more stable chair conformer. So if you think about the stable chair conformer, this is going to be the case in which they're all pointing down. So if we label this 1, 2, 3, label this 1, 2, 3, right? This methyl is pointing down, so it's equatorial. This chlorine is pointing up, so it's equatorial as well. And then this methyl group is pointing down, so it's equatorial as well. And so this is the strongly preferred conformer. Because everything is equatorial. But you can see that none of these are anti in one another. And so E2 can't happen in this conformer. And so it can only happen in the chair flip, which rarely exists because it's not energetically favorable. And so overall, the E2 mechanism here is going to go very slow. The E2 reaction here is going to be very, very slow. Let's take a look at another example. So in this case, we have this chlorine pointing up, and then we only have one methyl group. And so if we think about our beta hydrogen options, right, we want these things, the hydrogens, to be anti to one another. So we've got a hydrogen right here, and then we don't have actually an anti-hydrogen here. We only have in the same plane, right? If you drew out the chair conformer, of all of this, we could put this chlorine facing up as axial, and then this methyl group pointing down as axial. Again, this is not the energetically preferred one, but it can still happen. If we drew the hydrogen here, it cannot participate in any kind of E2 reaction, whereas this hydrogen here is free to participate in the E2 reaction. And even if you did a chair flip, so now this chlorine becomes equatorial. As does the methyl group, right? This hydrogen is now axial. You can see it's still not anti to the chlorine. And so we still can't have the B2 reaction happen here. And this hydrogen E2 cannot happen here either. And so you can see when we're talking about the E2 reactions, we can only have a base attack this orange hydrogen. And so if you think about the product forming there, this would be your one and only product. You would not have any elimination of this purple hydrogen, and so you would never form this product, even though it would be the more stable alkene, because the mechanism will not allow it. So again, just another tricky thing to keep track of, E2 reactions and cyclohexanes.